Hello, everybody. So let's start. I have only 20 minutes to tell you all the fun stuff. Well, this is about me. So very short. Just working full time about on MySQL performance. Extremely fun stuff, and I can you tell much more. So later, just I have only 20 minutes about. I'll try to do it in 15. And so, well, what are my main problems? So, in fact, if your problems are something, how to tune your query, or use in right way MySQL and so on, everything you can read from RTFM, it's not my problem. So my problem, you see, it's about what you cannot fix, which is broken by design or will not work by design and so on. So many problems are known, many problems we just discover, and well, work in progress. So it's a constant progress here. Historically, so from 5.5, MySQL 5.5 was, who already tested MySQL 8.0? Fine, guys. Who already moved it to 5.7 at least? So 5.5, you know, we delivered just well, some fixes which were already known. In 5.6, we started to do some deep changes, which bring huge pain because there was many regression, many differences, and so on. The most painful point in 5.6 was that writes were faster than reads. So in fact, if you want to read faster, you need to send some writes, and they will unlock your reads, and you will read faster. So it was completely odd, dumb, what you want. And in 5.7, finally, we fixed reads. So reads become faster, but we started to lose in efficiency. So there is always cost on something. We always balancing the code to get the most optimal stuff. So in 8.0, we are fighting, and I think it will be main fight for many years now, for efficiency to get the best possible performance on the same hardware. So we are not running for the bigger hardware. You should be more efficient the same way. So you will see some flame graphs. So it was huge progress on 5.7. You can see here, once we delivered on read-only, a monstrous result. We were so happy. Since this big machine was upgraded from 72 cores to 96, so we are happy to get more than 2 million query now. So okay, it's real numbers, it's possible. But the difference between 8.0 and 5.7, it's not really big. And in fact, well, we don't care about this anymore because we already saw that we can do 2.500.000. So for read-only, it's fine. We don't touch this. So there will be probably some regression because we added new stuff. Okay, but our main problems, it's everything which was remaining from 5.7. So I will just add potential fixes which we'll have here and speak about the problems. So on read-only, there is still remaining block locks, for example. So if you read constantly the same rows, you will have contention. So you will go just slower. The workaround here is just to use query cache or proxy SQL is query cache. There is no more query cache in 8.0, so proxy SQL is the best solution. Look up on secondary indexes on InnoDB can be many times slower than primary key. So the main workaround just to use primary key, or well, we are working in another solution to speed up all this stuff. There is also adaptive hash index if you enable, but well, the problem as soon as you have writes, it can slow down your stuff. So these are hot topics for us here. And for UTF-8, it's extremely faster now in 8.0. So before, for example, in 5.7, you can be 10 times slower if you use UTF-8. So at least in 8.0, it's only 10–20% slower than Latin 1. Huge progress here. For double write, so this all read-write problems. Double write is expected to be fixed in 8.0, so I will not speak here. I will tell you about the redo lock changes we are doing. Transaction locking and lock management. So I will speak to you about cuts, then coming with 8.0. Transaction isolation will still work in progress. There is a huge potential fix here. On update, performance directly related to redo logs. And insert performance, we are working here. Well, as soon as you keep B3 cached, like if you can use partitions or different tables, you can go very fast on insert. Otherwise, well, B3 is impacting you. And for purge, if purge is lagging in your production, so at least with 8.0, you can truncate, undo. So you can truncate as a space, which is your garbage collection, in fact. So, to be short, so we touch it, so we try to select the most killing problems that we have. So the most killing one is redo log. So as soon as you optimize it everything, and then you cannot write on redo log as fast as you want, you are blocked. So this is the final bottleneck that you hit. Well, except if you hit some other problems. If you don't hit them, so this is one. So for this one we attack it to fix an 8.0. Another one is every IO-bound workload. So in InnoDB we have global lock currently. As soon as you start to read something from the disk, every IO operation takes the global lock. So of course it cannot scale. And as you have faster and faster storage, you cannot do faster with faster storage. And so this is related to file system locking. And also so for row locking. So we take a contribution from Michigan University, so I will speak about this later. So now about the redo log. So what happens inside? So well, I suppose that you know, then we have a transaction commit. You know how to use them. So you flash on every commit or not, or once per second. So well, it was 3 years ago we discovered that we can go faster even if we flash on every commit. So in fact, the storage is not a problem. All the problem was about the locking inside. So all threads of user threads are fighting to write to redo log. And in fact, this was the old model. So you see the global lock, which is blocking everybody. And the new model, then we have dedicated log writer thread, log flasher thread, and notification threads around. So just simplified structure. So users are not blocked anymore. They are writing directly to the log buffer. And in parallel, we are flashing all this data to the disk. So in fact, we are blocked only by your storage performance. So faster you can write, faster will your redo log work. There is no more grouping, so we don't wait in. It's natural grouping by your flash speed on the disk. That's all. So you will go as fast as your storage can go. So this code is extremely well instrumented. So you can know exactly how many waits you have, what your threads are doing, so what happens inside. And all configuration is dynamic. So you can change whatever you want inside and see it. Even resize your buffers, log buffer, for example, live, or even stop all the redo log if you want. So this is multi-thread model now, but you have a trade-off. So with multi-thread, you never can be faster than single thread, which is just doing alone. So it will do write fsync, without any waits, without any synchronization. So of course it will go faster than the right place with threads. So there is a trade-off, and the only option, so we are disappointed that event-driven system cannot be as fast as spinning. So spinning is the most efficient way anyway. So this is painful. Probably later we will reinvent something more efficient, but currently only spinning helping to go as fast as single user doing the same actions. So you can imagine here, so what happens, well, just to give you an example. So if we do nothing, if we don't use redo log, so you can see this is where going, this is a red line. It's about the current 8.0. So if we don't do these changes on redo log, you see we don't reach the levels. So this is a, let's see me. This is the highest level that we get with spinning. But spinning, as soon as you eat a lot of CPU, so then you go down. So in fact, you need a balance between spinning and event-driven. And so currently what we decided, so it will be adaptive spinning. So in fact, okay, You can tune it list to say, okay, as soon as I reach this level of CPU usage, I don't want to spin anymore. Only as soon as my disk becomes slower than a given response time, I don't spin anymore. So at the end, it will be just auto-tuned. We will auto-discover what happens on your system, and you will don't touch anything. But as a first release, well, we prefer to give you some tuning points here. So what we have is this. For the first time, we present a result with transaction commit 1, because before it was never possible. As soon as you use 1, everything was slower. Now it becomes faster. So A2 becomes faster than 5.7 and 5.6 in pure LTP read-write test, and much more faster yet in pure update. So when you bombard and when you have heavy updates workload, so the difference you will see. What is amazing here, then you see in 5.7 we got huge regression here, and 5.7 is slower than 5.6. So in fact, we are 2 times faster than 5.7, fine, but we are getting back these regressions than we got since 5.6. So this was related to all this work about read-only improvement and so on. So we are still not scaling. Why? So because redo log is just the first step, and we have next layer lock. So all this transaction locking, lock management, and so on. So just to give you an example how it should be. So this is our prototype, so in current development version. And it's, so if A2 is not scaling on 1, so there's 1 CPU socket on the left side. So this is 1 CPU socket. And here, in fact, it's 2 CPU sockets. So we can reach 400,000 updates per second, which is enormous number, so never seen until now. But well, this work is in progress. I hope it will be fixed soon once we deliver A2. Now, what about I/O workloads? So, well, any I/O-bound workloads were blocked by storage until now. But now you have a huge game changer is flash storage, which is coming and become faster and faster and faster. And in reality, you have max throughput on your flash storage, but your real performance today is, is driven by I/O operations per second. So in fact, the throughput is limited, but you can like divide it like a memory access. So it's not like before, you know, then we tried to do bigger I/O to read more on whatever. Now you can read small I/O and you will still match the same throughput, but you will have more operations per second. Especially if you need to read few records from big block, you know, so it's smaller blocks will give you better performance. But in fact, what happens on InnoDB by default, we have 16K page, okay? So compression topic is very popular. So we say, okay, let's compress. Imagine when we can compress it 4 times. So we will be able to read 4 times more, because so page of 16K, compress it to 4K, and with the same throughput, we can read 4 more pages. Great. The problem is you have exactly the same buffer pool, so your memory is not 4 times bigger. So once you uncompress your data, it's still the same useful data sets. In fact, you can read faster, but you cannot use your data faster, because before to read, you need to process what you already have. Otherwise, why you read, right, this data? And what happens if you will just, instead of 16K page, use 4K page? In reality, in the same memory, you will have 4 times more useful data. And here, really, will go fast. So, of course, this works if you need only few data from the same page, not if you need the whole page. Otherwise, okay, this should be okay as well. But all the story is not possible just because we have this global lock mutex, so global lock for every I operation. So as soon as you're starting to read faster, this global lock is blocking you, so you cannot read it anymore. And so the good news is that in A2, we fixed this. So to validate these changes, so we got a chance to use the latest Intel Optane drive, which is alone able to deliver, you could imagine, so just 1 single thread, doing pure I/O can just read with 1 gigs per second. So 1,000 megabytes per second, one single thread. So in fact, using 2 drives like this, in theory, with 4K page, we are able to do 1 million reads per second. But is it true? This is the point. And in fact, yes. So we doing more than 1 million real I/O bound selects per second. So this is huge. So it's pure I/O bound point select here. And the same huge jump in updates, because in update it's much more expensive, so you can have to read the page, update the page, write the page, and so on. So you're constantly doing I/O operations. And well, this is the progress that we expected from a long time, and finally everything coming good on the same time. So we have storage solutions which are coming with Flash from any vendors, and we have code which will work with this. And for the last point, I wanted to tell you about the CATs. So in MySQL, it's called CATs. Initially, it was called VATs. And CATs is just contention-aware transaction scheduling. So it was invented by University of Michigan and adopted in MySQL now, so available since MySQL 8.0. So the idea is, well, looks pretty simple. So in fact, not all transactions are equal, and you have some transactions which will lock more data, some less. So some objects are more important, less important. So in fact, this is a simple schema. I put you links also here to read more about. So it's very long paper, scientific paper, explaining all the logic with many examples and so on. So in fact, how to decide, traditionally we just using FIFO and first coming first unlocked. But in fact, if you do it in more smart way, so you don't unlock the transaction which came first, but transaction which is blocking more others, you have better performance. But in fact, all the story, it was much more fun than this, because it's turned into a real detective story, in fact. So there was a claim about huge performance improvement, but as soon as I started to test it, so any probe test did not show any difference. No gain, 0, or you're just going slower. So, well, we started a long investigation and discussion with guys from Michigan. Well, because the first impression was they are just kidding, there is nothing real, just it's fun something around. And they know MariaDB already applied the patch, so everything is working. Shit, we did not see any results, okay. So we started to understand what they want to solve. Finally, so I found the way to build a scenario which shows the difference. So then it was big UP. Finally, we can see what could be improved. And as soon as we started to see the workload, Sunny started discovering bugs and bugs in the patch. And then it started to loop, in fact, on the remastering, fixing, retesting again. Do we have again? We lost again. We got again. Another bug is open, and so on. So, well, in fact, well, it's probably we spent 9 months on this, in many loops, before fixing everything. And at the end, it was still unclear in which way you should use which algorithm. And again, DBA cannot sit down and look on the workload and say, okay, let's 5 minutes run this one, or now I switch to another model again. So finally, we've come with solution which auto-detecting the problem, and then you will switch from FIFO or CATs according to what is better for you in your current workload. So we'll just discover how many logs you have and decide what is better. So it helps everywhere when you have raw log contention. How you can recognize it, just follow your show engine mutex output, and you will see if you have logs on your current workload or not. So in fact, you need to, well, somebody never monitors the production? Well, bad questions. Everybody monitors production, right? So, well, you monitor this all the time. So of course you will see your spikes, and you will see, okay, it's your case. So you will be happy with 8.0. And so here is example with a low-level Pareto distribution. So it means then you will have artificial contention on data, and many threads, many users will fight for the same data. So with a growing load, you can see them. So without this algorithm, you lose performance with growing load. With this one, at least you solve something. Okay, but you should be also realists. And well, if you write your application and you lock every time everything, so well, you're just bad programmer, right? So you try to avoid locking, in fact. So it's because it's by design in your application, so you don't want to create problems. And main problems are coming mostly because in InnoDB we have repeatable read transaction isolation. Okay, we want to move to committed read. The problem is, and this currently it's creating even more problems because of transaction locking. But this is a way what we'll do. But in fact, even in this case, when you can use read commit, you don't see any difference, you know. You use what or you don't use or whatever, everything is fine. So, well, I think once we'll deliver all the fixes that we want, everything will be transparent and equal. You'll be much more happy, even, well, than before and with this solution as well. So, go to action, download this stuff, and the most important point, have fun, because otherwise we are doing nothing and our job is stupid. So if you don't have fun, this is the point. Thank you. I'm on time. No time for a question.
Yes. So why I will set up Giuseppe, you can answer a question just
good.
there.
So any questions? Yep. Yep. Well, so in fact, the main problem with double write, you see, is okay. Currently, so you just have a small double write buffer, which is very small, and especially then you have locking inside. So in fact, what is the problem with double write? So this is the only protection we have today because of corrupted pages. And what's amazing, then no storage vendor can on Linux can support you, then you will not have corrupted pages. There is no support. So in fact, you need to write it twice every page. And the only problem is then you need to write them sequentially. So in fact, your write time will be 2 times bigger. So as soon as you can write 2 times more in parallel, everything is fine. So the new solution is just allowing you to write faster in parallel, and because you will have many writes, concurrent runs going together, and you will hide this latency time, which is increased by 2. It's not bigger, it will be unlocked in fact. So you are mostly blocked only by storage. Currently you are blocked by design. So this is a problem. But as soon as NVRAM will come, you know, so you don't need storage anymore. Because the problem when you write twice, you will kill your flash device, for example, 2 times faster. So as soon as you will have NVRAM, which you can rewrite any time as you want, and it's battery protected, so you don't care anymore. It will just go in memory and it's fine. Yeah, but this is double write. First write to memory and it's protected, and then you write to disk. So at least one will be safe. So it's fine. Other question? Yeah. Well, so we are working on full redesign of transaction management. So in fact, all this locking which happens today, which may kill you, I have a detailed blog post, for example, explaining the stuff around why it could be dangerous. So as soon as this locking will go, you will be just happy with committed read. So, you know, so just be patient. It's coming. No question? Okay.
Thank you, Dimitri.
You're welcome.